we were. We had a long fatty acid chain, right? And it has a C double bond O and an OH at the end. We have this glycerol thing where it's got, this is its carbon in the middle, this is its 2 carbon, right? 1. And carbon 1 is the CH2OH. What are we doing? We're attaching this fatty acid to this number 1 carbon, okay? How did we do that? So, what did this have on it? It had an H. Now in Switter ionic configuration, it might just be COO minus, but we're going to leave the H there just for fun, okay? So, what did we take away, right? We got rid of one of the O's, so we're adding up here. So we're adding this box right here to this box right here, okay? These two things are being joined together. So we kept the double bond OC, that's this one. This C double bond O from the fatty acid, right, is right here.
Okay.
Does that make sense? So this is a separate molecule. This is a separate molecule. We're going from a carboxylic acid, which is a C double bond O, OH, to an ester linkage, which is, right, the OC double bond O, rest of the molecule. So how do we get there? So we have 2 choices, and it doesn't really matter which one we use. We're adding, so we're basically taking this OH, putting them together, and leaving ourselves with an O. So we take this OH plus this OH, right? We end up with 1 O, because that's what's attached to the rest of the molecule, right? And then, so what did we take out? We had 2 O's and 2 H's. All we're left with is an O.
So
What
Water.
goes?
water.
Okay.
Okay.
It's not always as direct as that, right? I mean, water does a lot of different things in our universe. But, okay, so this is a carboxylic acid group, C double bond O, OH. Here's the C double bond O and the fatty acid attached to that C double bond O. It's attached in its entirety to the carbon in the glycerol by joining with the OH. Here's an OH group, here's an OH group. One of these O's has to become this O. It doesn't really matter which O becomes that O, right? Because there are 2 O's and they're pretty equivalent, all right? The other one has to leave along with 2 hydrogens. There just isn't any room for hydrogen anymore because oxygen only likes 2. And so when you take oxygen and you keep it bonded here, right, and then you need to bond it to this, the hydrogens have to go. So when you look at this molecule and it looks totally strange and you're like, where did it come from? Where it actually came from is these 2 hydroxyl groups joined together. They left 1 oxygen, the other oxygen and the hydrogens left.
And where do they go?
Well, wherever this goes.
Niagara.
Yeah, where it doesn't matter, yeah. So,
Slowly.
yes, question.
Solidification.
Just a simple thing.